Okay, good day, good people. Let us look at hydraulics. Let's work on our hydraulics. Um, okay, an effort of 134 is applied to the end of the lever. Let's take out our data, the given information. We are given F effort equals to 134 newtons. The mechanical advantage, it is given as 12. The diameter of the plunger, the diameter of the piece of the plunger, it is given as 25 mil. Let's convert it to meters. It will be 0.025 meters. Then we are given as well the diameter of the beak, or rather the diameter of the ram. It is given as 203 millimeters. In converting it to meters, it will be 0.203 meters. Then we are given as well the efficiency of 80%. Now they want us to calculate the W, but in this case they are saying calculate the weight exerted by the ram. They want us to calculate W, but we will go to the extent of calculating its mass. Now, in calculating the W, we will be using this formula. W over F load equals to the big D over small d squared. Sorry about it. Then in making the W the subject of the formula, it will be FL multiplied by big D over small d. But unfortunately, we don't have the FL. We then have to use the mechanical advantage formula in calculating the FL. FL over F effort. Now, don't forget that the F load it is affected by efficiency, then the F effort it is always assumed to be at 100%. Now, we then have to make the FL the subject of the formula. It will be FL equals to MA multiplied by F effort. Okay. Our mechanical advantage it is given as 12 multiplied by F effort, it is 134. Then we get our answer as 1608 newtons. But check this, we've calculated our F load out of 100%, and yet we are told that our F, just a minute, good people, just a minute. Right, in continuing, we, as I was saying, that our F load it is at 100%, and yet we are told that our pump it is 80% effective. We are told that our pump it is 80% effective. We then have to reduce this F load because it is out of 100%. We then have to reduce it to the requirement spec. We then have to multiply by 80 divided by 100, or 0.8. Then in multiplying by that, we get our answer as 1286.4 newtons. Okay. Now we can then use this force to calculate our W. It is 1286.4 multiplied by big D 0.203 squared divided by 0.025 squared. Then we get our answer as 84.818 kilo newtons. Now, this is our W. In calculating our mass, we then have to divide by 9.81. In dividing by 9.81, we get our answer as 8,646.077 kg. Now, this is the mass lifted on the ram side. This is the force exerted by the ram side. Okay. Now let's look at question B. Question 2. In question 2, let's take out the data. The first this question, we deal with the hand plunger pump. Okay. Then question 2, we are dealing with the piston pump. Now let's take out the data, the given information. The plunger of the 3 cylinders, our C equals to 3. There it is. We are told the plunger of a 3, there's 3 cylinders connected to a crankshaft, and each diameter it is 80. The stroke length it is 260. And now let's take out the data. C it is 3. Diameter equals to 80. Converting it to meters would be 0.08 meters. Then the stroke length, it is 260 mil. It will be 0.26 meters. Then we are given the pressure. We are given the pressure equals to 800 kilopascal. Now they want us to calculate the power required to drive. Now in calculating, and we are given the efficiency of 80 and the N. The rotational frequency is given as 160 R per minute. Okay. Now, it is efficiency equals to power out over power in multiplied by 100%. Now, they want us to calculate power in. In calculating power in, it will be power in equals to power out over efficiency. Now, let's look at how to calculate power. Power equals to work done over time. Now let's look at how to calculate work done. Work done, it is force multiplied by distance, or it can be pressure multiplied by volume. That would be your work done. It will be pressure multiplied by volume. But as soon as your volume, it is volume per time. You are now calculating what? Power. Now this is the route that we'll be using to calculate power, looking at the given information. Now in calculating power out, now, in calculating the volume per time, we are having pressure multiplied by volume per time over, or here we can say multiply by 100% divide by the efficiency 80. That's how we'll deal with it, just to make our life easy. Now, pressure it is given as 800 times 10 to the power 3 multiplied by remember, in calculating the volume, it is area, stroke length, number of cylinders multiplied by, if we are calculating volume per time, multiplied by rotational frequency. Now it will be pi multiplied by small diameter 0.08 squared divided by 4 multiplied by L 0.26 multiplied by C, it is 3 multiplied by 160 divided by 60. Okay, then it will be multiplied by 100 divided by 80. The 100 divided by 80, it is that one of your efficiency. Remember, your efficiency it is given as what? As 80%. The 80%, it is one the same thing as 80 divided by 100. Okay, that's exactly what I did there. Okay, then we get our answer on the efficiency as 10 for 10,455,22 watts. This is how you tackle this equation in calculating the power there. Now, question B, they want us to calculate the volume of water delivered per minute in liters if there is a slip of 6%. Now, check here. Here we had to convert this into R per second, and we had to divide by what? By 60. That's exactly what we did here. We divided by 60. That's exactly what we did here. But now, question B, they want us to calculate the volume per minute. That means in calculating the volume here on number B, we're not going to divide by 60 because our rotational frequency is R per minute. We'll leave it as it is, as 160. Now let's wipe so as to be able to tackle that question. Let's wipe here. Okay. I would use a different color. Let's use the green. Now, in calculating the volume of water delivered per minute, volume of water delivered per minute, and remember they want the fact check in liters. They want it in liters. That means it will be liters per minute. We then have to calculate our volume per minute. After calculating volume per minute, then we convert. How do we convert? We know that 1 cubic equals to 1000 liters. It means in converting cubic to liters, we multiply by 1000. In converting liters to cubic, we divide by 1000. Now, this is the root that will be taken to calculate that. Okay, let's wipe so as to be able to calculate. Okay. Now, volume, we'll study this volume per minute equals to area stroke length number of cylinders multiplied by n per minute. Now, check this. We are given the slip of 6%. What is a slip? Slip is a loss of fluid. Loss of fluid or leakage of fluid. Right. It's something that we have lost. Let's say we are given, we are working with the 20-liter container. Then we've lost 6% of that 20 liters. It means that which is left, it is 94% of 20 liters. We are now having the actual percentage that we can work with. Now here it will be multiplied by actual percentage. Because slip, it is something that we have lost. It is not there. It is the loss of fluid, the leakage of fluid. Now, we then have to work with what it is left. Now it will be pi multiplied by 0.08 squared divided by 4 multiplied by 0.26 multiplied by 3 multiplied by 160 per minute. Remember, they want our answer in liters per minute. Okay, multiplied by the actual percentage would be 0.94 because we've lost the slip. It is something that it's been lost. Okay, then our answer here would be pi would be pi multiplied by 0.08 squared divided by 4 multiplied by 0.26 multiplied by 3 multiplied by 160 multiplied by 0.94. Now I get my, where's my writing tool now? Why is it not appearing? I get my volume per minute at 0.5897. Right? This would be in cubic per minute. Okay. Now, I did indicate that we need to convert it to liters because that's exactly what they want. They want us to give their answer in liters. Right. It means we need to multiply by 1000. We need to multiply by 1000. Now, when we multiply by 1000, we get our answer as 589, 674 liters per minute. It means the liters which are delivered per minute, it is 500. That's what it's being delivered per minute. This is how you tackle these questions of your hydraulics. Thank you, good people.